Okay, so let's do in class 7, number 2. So we have to maximize the function x squared yz subject to the constraints x plus y plus z is 32, x minus y plus z is 0. So I'm going to call this first constraint, this part g, and this h, and call the 32 to k, and the 0 is c. So we're going to use Lagrange multipliers to solve this. So here's the system we're going to have to solve. Okay, so let's start finding these things here. So note here. So f(x) in our case, here's my guy up here, so it's going to be 2x yz. Fy will be x squared z. F of z will be x squared y. Say g of x. Here's my g here, so we just 1. G of y, also just 1. G of z, also just going to be 1. H of x will just be 1. H of y will be minus 1. And lastly, h of z will be 1 also. Okay, so let's plug into our system then. So plugging into our system here. So we'll get then fx, so it'll be 2x, y, z equals lambda times g of x. So lambda times g of x here is 1, plus mu times h of x is 1 also. Let's call this equation 1. Here a bit. Okay, and then we have fy, so fy is x squared z equals lambda times gy, which is 1, plus mu times hy, which is minus 1. Call this equation 2. Okay, then fz, so x squared y equals lambda times gz, 1, u times hz, which is 1 also. Equation 3. Now have our two constraints. So our constraints were x plus y plus z is 32. On equation 4, and x minus y plus z equals 0, call that equation 5. Okay, so to try and solve the system then, so let's make some observations here. So let's keep going here. Okay, so note here, so from equation 1 and equation 2, notice they both have lambda plus mu here and here. So it means that this needs to equal that for equation 1 and equation 3. And we have both these sides equal, so it means these must equal. We have 2x yz equals x squared y. Okay, so now if x is not equal to 0 and y is not equal to 0, we have so we can divide both sides by x, y will have then 2z, oh no, I guess it's 2xyz equals x squared y, so divide both sides by xy. So you have then 2z equals x. Now we can substitute this into, say, equation 4. So sub into equation 4. So equation 4 is here. So in place of x, I can put 2z here. So right here. We get, so doing that we'll have then 2z in place of x plus y plus z equals 32. So we get then that moving things around here, let's solve for y. So y then, combine the z's, bring it over there, would equal 32 minus 3z. So let's box that for now. Okay. So now we're going to sub y equal to 32 minus 3z and x equals 2z into the equation 5. So here's equation 5 over here. So I'm going to put 32 minus 3z in place of y here. And in place of x, I'm going to put in 2z here. Okay, so let's make these substitutions. Okay, so we're making our substitutions here and here. So doing that, we get so 2z minus 32 minus 3z plus z equals 0. Okay, so simplifying this, we get then plus 6z, because that'll be 3z there, another one there, and 2 there, will be 6z. Minus 32 is 0. So solving for z, now z equals 32 over 6, which reduces to 16 over 3. So now x equals 2z implies that 2 times 16 over 3 is my x. So it'll be 32 over 3. And my y, over here, y is equal to 32 minus 3z. So it'll be 32 minus 3z. And z is 16 over 3, so it'll be 32 minus 3 times 16 over 3. 32 here. 3's cancel, we just looks like we just got 16 for this one. So hence extrema at f of so our x was 32 over 3, our y is 16, and our z is 16 over 3. So we still need to figure out whether it's going to be a max or a min. So still need to determine if we have a max or min. Okay, so how are we going to determine this? Well, we're going to have to pick a test point on the on our constraint here. So we'll take a look at that now. Okay, so we still need to determine if our f of 32 over 3, comma 16, comma 16 over 3 is a max or min. So recall, here's our constraints. So it was equation 4 and equation 5 in our system. So let's find a point that's on the constraint, on both constraints. So we can try, you just look at that and try and guess a point, or another way to do it is we could solve the system. So let's say to eliminate x and y, we're going to go, say, equation 4 minus equation 5. So we did a minus here. So it'd be then x minus x will cancel, be y minus a y, so it'd be plus y there, so it'd be 2 y's, and it'll be z minus z, gone. So this implies that, so we'd have 2y equals 32, so then dividing by 2, y is 16. Then substituting that into equation 4 then. So have then x plus 16 plus z equals 32. So subtracting 16 on both sides. Yeah, then x plus z equals 16. And you just need to make that true. There's many different choices. So let's say z equals 0, then x is 16. So hence 16 was a y, 16, 16, 0 is on both constraints. Okay, so let's recall now, recall our f of xy was equal to, right down here, oh sorry, hold on. fxyz was equal to x squared yz. Okay, so let's evaluate now at 16, 16, 0, and this guy, and let's compare. So now, let's look at f of our 32 over 3, 16, 16 over 3. So it's going to be x squared, so it'll be 32 over 3 squared times y times 16 times z, 16 over 3. Okay, so working this out, I'll let you check, is roughly equal to, say, 9,709.04. And let's look at the other point, the 16, 16, 0. It's going to be 16 squared times y, 16 times 0. Well, this guy is 0. Well, by Lagrange multipliers, we know this guy has to be an extreme, either relative max or min. So it's larger than this one. So therefore, the only choice is this has to be a max. So hence, f of 32 over 3, 16, 16 over 3 must be a relative max. Okay, so whenever you have just one point, like this guy who just found one answer from Lagrange multipliers, we're going to have to compare it with a test point to decide whether it's going to be a max or a min. Okay. Let me mention one more thing. Along the way, at one point we did assume that x was not 0 and y was not 0. So therefore, I'll let you go back and check if either x is 0 or y is 0, that will not lead to a solution of the system that we had. So therefore, this is the only answer, so we're done.